Hi everyone, welcome to our video on using given conditions to solve initial value problems. And all it is just, we're just going to take, let me move that a little bit, there we go. All we're going to do is take the antiderivative and then we'll eventually plug stuff into our function that we find so that we can find whatever the constant is. So we're going to get an actual number for the constant. One of the common ones that we see in this class is involving marginal cost, but it could be really anything. It just doesn't, it really doesn't matter. As long as you have some given information, we can use this scenario to help us. Okay, so find the cost function for the marginal cost function. So remember, so if we have cost, the derivative is the marginal cost. Okay, so that's our marginal cost notation. So that means, well, if we were to go backwards, that would be the antiderivative. Okay, so that's why I want to, so step one, I'm going to find the antiderivative. I'm just going to do anti ... Okay, and let's go ahead and rewrite it though. So c prime of x is 0.5 x squared. So this I'd rather see as plus x to the negative 2, like that. Okay, and then now I can find the antiderivative. I'll do that in blue. So so just like right here, so c prime of x, the antiderivative is just the cost function. So we'll have just c of x equals, and then we'll follow our steps. Well, the 0.5 is just hanging out. And then x squared's antiderivative is add 1 to the power to get x cubed, and then multiply the front by the reciprocal, so 1/3. And then we have plus, really, though there would be a 1 hanging out in front. I'm going to use that as a placeholder. And then add 1 to the power would give us x to the negative 1. And then multiply by the reciprocal, which would be negative 1/1. And then plus our constant c. Now, this constant c is just a generic letter. It's not part of this cost like this c. So if you want to change it, you can, but it's usually just left as our capital C, and we know eventually it will change into a number for these problems. Okay, but before we keep going, let's go ahead and just simplify what we have. So we have the antiderivative, so let's write it as c of x. So 0.5 and 1/3, since they're using, it's a mixture, well, they use the decimal to start. I'm going to go ahead and, again, just plug in my calculator real quick. So it would be 0.5 divided by 3, which gives us this value here, 0.16666, so forth. Or if we were to change it to a fraction, I guess 0.5 would be 1/2. So 1/2 times 1/3. Let's actually do it as a fraction, 1/6 x cubed. And then this would be minus x to the negative 1 plus our constant. Okay, so I'm going to cloud this. So this is our cost function so far. And again, maybe a quick check with the derivative. So if I were to do the derivative, c prime of x, so this is just a quick check. Well, the 3 would multiply the 1/6, and that would be 1/2 x squared. Negative and a negative would become positive. Minus 1 would be x to the negative 2. And yeah, that matches what we had up at the start. Okay, so the check is good. Okay, but now I need to continue on with the problem. So step 2, I'm going to use this information. Okay, so we're going to use the info 10 units, cost $120 into our function. Let's go ahead and write it. I'm going to write it right below, and we'll label some things in just a second. So I'm going to use this guy right here. Okay, so we'll use this info. So 10 units. Well, we're assuming the units is x because the cost is c of x. So this whole thing, that is c of x. Okay, so what we have then is we're going to plug 10 in. Let's use the highlighter. We're going to plug 10 in right there and right there for our x value. And then we'll plug in the pink, let's use pink, the 120 for this whole thing. So that's all they want us to do. So we'll just plug all of that in. Okay, so the pink we're going to say is 120 equals 1/6, and then x we're saying is 10, but it's going to get cubed, minus, this is also just 10, but it's to the negative 1, plus our cost. Or not plus our cost. See, I did it. It's just plus our c, just a random constant c, plus our constant. Okay, and then now I want to solve for this. Solve for that c. Okay, so if we solve for c, well, this is now just arithmetic, so it looks like we'll have, we'll probably need a calculator real quick because of the decimals, but this would be, so 10 cubed is 1,000, and it'd be divided by 6. 10 to the negative 1 is really minus 1/10, using our rules for what that negative power does. Remember, it just flips it, and then we have plus our constant right here. Okay, and so at this point, I'm going to use the calculator to simplify. So I do have 1,000 divided by 6, and then we're going to minus 1/10 from that. And it gives us that. Okay, so we have this 166.56. Okay, so we've got I'm going to move that to the side. So we have 120 equals 166 let's do 2 decimals, so we'll just say 57 plus our constant. And then, well, I could just subtract that on over minus 166.57. Okay, and let me use the calculator one more time here where I've got it on my other screen. Now it's here. Okay, so I want to do 120 minus 166.57, and it gives us negative 46.57. Okay, so we just found our C. Okay, so we have our C is negative 46.57. Okay, and then now, okay, so I only have 2 steps, but we do have a 3rd step. We need to finish it. Okay, so let me cloud this. So this is our little C here. Well, I'm going to use one more highlighter. Let's do it in a different color. Let's do green. So they're saying this should go right there for that C. Okay, so then we'll have our final answer. So step 3 is really plug in our 2 equations right here. So our final answer, I'm just going to write it as step 3. All right, so we have our cost function. So it's rewrite the cost function. C of x equals 1/6 x cubed minus x to the negative 1. And then plus this negative, let's just go ahead and say minus 46.57. Okay, so there we go. Okay, so we get a weird, this is not a realistic cost function. For one reason, you can't plug 0 in because that would be undefined. Okay, so we have an issue with this. Okay, but it's just abstract anyway. So for at least in this scenario, okay, so they might ask some questions like that sometimes. Is this a realistic cost function? No, this one's not, because 1, you can't plug 0 in. So it's like saying you can't even plug in 0 units. Okay, but that's okay. It worked for us in this problem. Okay, and it did kind of encroach on our other part here, so I'm just gonna block it off, and I think we'll have enough room. Let's find out. Okay, well let's break this down. Okay, so we go ahead and just block it all the way off. Okay, so in number 2, I want to do the same thing. It's still take your antiderivative. This is ready to go. I don't need to rewrite anything. So C of x is the antiderivative of 6e to the x is 6e to the x. The antiderivative of minus 5 would be, hey, just attach x to it. Okay, so it looks like that. And then we have plus our constant c at the end. Okay, so this is our cost function. It doesn't even need simplifying. So let's go ahead and just cloud that right now. Okay, and then they give us a different scenario where they say fixed cost is $20. Okay, so what that means is when you produce 0 units is $20, or let's say 0 units cost $20. So that's the only difference with that. So 0 units cost $20. Okay, so when you see fixed cost, that's what this means. So the main thing is 0 units cost that amount. Okay, which means that is our x in this problem. So x is 0, and then this is the whole cost function. So just like the last one, we'll plug it in. So the x is 0, so we'll change all those x's to zeros, and then we'll change our whole cost function into 20. Okay, so now step 2, we're using the info. Okay, so we're saying this whole thing right there is 20 equals 6e to the 0, so x is 0, minus 5 times 0 plus our capital C. Okay, and then now we'll start to simplify, so we'll solve. So we have 20 equals 6e to the 0 is just 6. 5 times 0 is 0 plus our constant. And then if I subtract the 6 over, we're going to get 14 is the C. There we go. Okay, so now step 1, step 2 are done. Our third step is just to rewrite the cost function. So I have capital C of x is the 6e to the x minus 5x plus this 14. So that's our last step there. There it is. Okay, so that's our final answer. Okay, so I put the kind of the harder one first. The second one is just with a different scenario with fixed costs. We just have to make sure we can decipher it. Okay, so that is our scenario with finding initial value problems. So this is so initial value problems is just mean we're solving for C eventually. Solving for that arbitrary constant C. Okay, so let's do one more. Here we've got find the demand function for the marginal revenue function. Recall that if no items are sold, the revenue is $0. Okay, so they give us a little hint there. Okay, one thing we need to remember. Okay, so the demand function is from the revenue function. So revenue is equal to price times quantity. Okay, so that's our revenue function. And so let's get our revenue function. Okay, so if we have marginal revenue, so marginal revenue, just like, let me just scroll, just like with our cost, if we have marginal revenue, taking the antiderivative would give us the revenue. So what I want to do is find the antiderivative again. And it looks like it's set up also already, so let's set it up in blue. So my revenue function is 50 and attach the x, and then minus the 2's hanging out. All right, here we have an e to a constant x, so we're going to copy and paste the e to the 0.05x, and then we just have to remember divide by that constant that's attached to the x there, 0.05, and then plus our constant c. Okay, and then we'll simplify. So we have our revenue function is 50x minus, now the 2 divided by 0.05, I'm going to do in a calculator again. 2 divided by 0.05 is 40. Okay, so we have 40, so minus 40 e to the 0.05x. And then plus our constant. Okay, so this is our revenue function so far. So I'm going to cloud it. And then, well, let's use this information. No items are sold. The revenue is $0. Okay, so with this information right here, this is our step 2. Okay, so they're saying if no items are sold, so that means when x equals 0, r of x also needs to equal 0. So we're gonna replace the r of x. Let me go ahead and I'll just highlight it on here. This is going to be 0, and then every x that we have will also turn into 0. Okay, so what this becomes is, all right, so we have r of x, the whole thing is 0, equals 50 times 0 minus 40 e to the 0.05 times 0 plus our constant. And then we'll start to solve. Well, I have 0 equals 50 times 0 is 0. This whole thing simplifies, so this is e to the 0 right here. Let me just put it in brackets. E to the 0 is 1, so that would times the negative 40, so it is negative 40 plus that random arbitrary constant c. So all I have to do is add 40 to the other side, If we add 40 to the other side, we would have 40 is C. Okay, so now that's now letting us do our step 3 where we could change our revenue function or we could rewrite it using that arbitrary constant. So we have r of x equals 50x minus 40 e to the 0.05 x plus our 40. Okay, so that's this expression so far. So this is the revenue, but that's not the final answer. They said find the demand function. Okay, so the demand function really is the quantity. So they want us to find the demand function, which is really our quantity function. Okay, or it's our quantity, let's say quantity and price. It's kind of mixed in the middle there. Okay, so let's figure out what that is. So the demand function usually has both of these letters involved. All right, so let's break this down with our revenue. So we have, let me go to our revenue. What color do I want to use? Let's do purple. Okay, so let's come back to this. So our revenue is the R of X equals whatever the price is. Now the quantity, so that's why I said the demand is quantity and price. In this problem, the quantity is just going to be X. Okay, because we're assuming the X is the items that are being sold. And then our price function is P of X, like that. Okay, so it's some expression. So P of X is a function. So let's set this all up. So on my left, I have R of X, which I'm going to rewrite as, okay, let me put the purple actually right here. And we'll show what I'm going to do with my substitution. Okay, so what I want for my R of X is this whole thing. I'm just going to rewrite that on the left side. So I have 50x minus 40 e to the 0.05 x plus 40 equals P of X is what we're trying to find. So I'm going to leave it as P of X. And then we still have times X. Okay, so we're going to find this P of X because that's the only other function that we have. And then, well, all I have to do then is to divide by that X on both sides all the way through. And I'm going to do it as one big fraction. They might change it, but I'm going to do it as one big fraction like this, which gives us our price function. Okay, so we have 50x minus 40 e to the 0.5x plus 40 all over x. Okay, that's it. So this is our demand function because it has price. Now they might change it. They might just say it's P. Okay, so they might just change it to, let's write it like this. And they might change x to be like Q. Okay, so I'm going to write it as little p on the left equals this whole fraction. Nope, I left a 0 out on that one. Let me put that there. There. 0.5x plus 40 all over x. So often x is q, but on this problem they kept it as x. Okay, so it's really just one extra step once you have your revenue. It's just divide by x is probably the better way to say it. Okay, but that's it. Okay, so this is again is an initial value problem, which just means we're trying to solve for C. So whenever they give you some extra information with these types of problems, so like the 10 units cost 120 or whatever, it just means you want to find that constant C eventually. Okay, so that's it. Hope that helps. If it doesn't, let me know. Ask me questions. Okay, so otherwise, thanks for watching, and I'll see you again next time.